Okay. First of all, can everyone hear me?
Yes.
Yes.
Yeah.
Yes.
Yeah.
Right. Nice. So first of all, welcome to the course. Um, I know that some of you attended the meeting yesterday. Some of you had an issue. It's all right. We'll resolve every issue we find. So I first want to say again that our goal here is to teach you the basics of both neuroscience and programming, so that then you can also start to connect them in some interesting ways, maybe connect them in the direction of AI or in the direction of brain devices or whatever direction you prefer. There's a lot of intersections. But mostly here we'll be covering the fundamentals of coding and the fundamentals of neuroscience, how the brain works and such, and a little bit of intersection with the two of them. Now, first, before we actually get into the stuff, I want to quickly explain what I mean by intersection. And one example of intersection of programming and neuroscience is EEGs. Maybe some of you have heard. So EEG is electroencephalogram. It's a device used to measure brain activity of people, which we can actually use to, for example, figure out when someone is stressed, when someone is focused, when someone is thinking of moving his hand and such. And actually, these EEGs can even be bought. Like, for example, this is one such device. This is called a Neurosity Crown. I'll put a link to it if anyone is interested in getting one. Basically, these kinds of devices let us write code that will work for our brain. For example, I can put this on my head, and what I can do is I can say every time I think of moving my left hand, take a screenshot on my laptop or send some message or just take an action. So what this allows is to basically connect our brains with the internet and with computer, and but kind of unlocks a lot of opportunities, which is what I like personally about doing neuroscience and programming together. Or maybe you might just use it to do deep research in neuroscience, which would require programming, or maybe you want to do some work in artificial intelligence, which can be inspired by how the brain works, or, well, basically, there's a lot of ways that these fields intersect. So I would just want to make sure that I inspire you and I can give you the fundamentals. So yesterday you covered some basics of how the brain works. Today we'll cover the very basics of programming, like variables, running code, printing to the screen, and then step by step every week we'll build up on that. So far, is everything clear?
Yes.
Yes.
Okay, nice. So I'll start by just introducing myself, I guess. So I'm Nika. I'm a computer science student right now at Kutaisi International University, and also I'm a software engineer at Microsoft. I write code mostly, but recently, like about a year ago, I started getting into neuroscience because I like to follow the tech trends, which I recommend everyone here to do. And it seems that we'll be the first generation that will very seriously start using brain devices to control our, basically, like increase our focus, increase our self-control, and eventually even increase our intelligence and, let's just say, upgrade our minds. And that's something that I like, and that's why I'm in this field. You might not like that. Maybe you prefer other fields. I mean, other aspects of this field. That's fine. But either way, I think you'll benefit from having the fundamentals of programming and neuroscience, basically. Right. So for these lectures, we'll be using Python language because the way I see it, Python is one of the easiest to learn. And also, actually, it's used the most in all kinds of neuroscience research and just basically in all of science. So Python is, I think, the best programming language for this kind of stuff. And so, yeah, we'll be using it. After this meeting, I will send some links for how to set it up perfectly, what's the best way to run it on your machine and such. Today, we won't bother with that. Today, I'll just share my screen and we'll just discuss it together. But afterwards, yeah, every one of you will set them up because you will have homeworks that will be sometimes about neuroscience, sometimes programming related, sometimes both, and you'll have to write some code in homeworks. And seriously, I highly recommend that you do the homeworks because a lot of the learning comes from struggling, you and failing, and then figuring out how to make things work. Okay, so far, are there any questions?
No.
Yes? By the way, if your microphone is not working, you can write in the chat. I'll be looking at that as well. Okay, I guess I'll start with the basics of Python for today, and incrementally we'll build on it to get to a more advanced level and then eventually to start integrating the brain devices as well. And in the last week, we'll actually use this a bit as well. Okay, let me share my screen. Can you see my screen?
Yes.
Okay.
Yes.
Right. So the app that I'm using right now is called Visual Studio Code. Basically, there's many different apps you can use in which you can write your code, look at your code, run your code. It's just a more comfortable form of programming. You could obviously just do everything in Notepad, directly just write some text and then run it, but this is just more convenient, more comfortable. So I recommend that everyone here gets Visual Studio Code. Right after this lecture, I will put links and tutorials and everything in our Discord group. But right now, let's just get into this. Don't worry about doing it right now. Let's just figure it out together. So in Visual Studio Code, it looks like this. Here we can create new files or new folders to organize our code base. Let's just start with the basics. Let's just say basics.py. So you know how different text files have different endings? Like, for example, photos have .png or .jpeg. And code files usually have dot and whatever the programming language is. So for Python files, it's .py. So in this case, whatever we write here will be Python code, which we can then execute. For now, let's just start with the absolute basics. Let's just write hello to the screen. So here we can just say print hello. And when I click on the run button here, right here you can see it. This runs and we see hello printed on the screen. Now, this doesn't seem like much, perhaps, but step by this, we'll get to a point where we can meaningfully start interacting with our brain devices, with neuroscience, with AIs, and with everything, simply by this very primitive and easy to understand building blocks. So the first building block to understand is the print statement in Python, which here's how it works. We say print, we open our brackets, and whatever we put inside there will be on the screen. So like we can say 34, for example. We can say 3 plus 4, in which case we'll get just 7 on the screen. We can say 3 times 4, well, we will get 12. We can say 3 divided by 4 and get 0.75 and so on. So the point is, in Python, we can do a lot of different operations. And for each operation, then whatever result we get, we can print on the screen or we can use it in something. So interesting point to note is that we can construct any complicated operations, anything that a human brain could do. So here's the thing, anything we can do with our minds, like say someone asks us to solve a math problem or maybe solve something in real life, in principle, a computer can also do. It just comes down to how well can we explain what we want to be done. Let's start with very simple things. For example, for now, let's just say, what is 2 plus 2? We will get 4. What is 2 plus 2 times 2? In this case, what do you think will be the answer?
6.
Yeah, obviously, yeah, 6 because multiplication happens first and then addition. So these kinds of rules Python respects. And also just one more thing to mention here is that in Python, we can also use powers. So this just means 2 to the power of 3. So this will just write 8. Like we can say 3 to the power of 3, which is 27, 3 to the power of 4, which is 81, and so on. So basically what we need to understand is, and by the way, when we write a hashtag, everything that we write here is going to be just a comment that will be ignored. So nobody will care about this. So here, if we just say hi, only the hi line executes. This doesn't execute at all. So we can just write whatever we want here as comments so that we can explain our code. And so that we can, if we come back to it, like say a week later or a month later, we can still know what's going on here. So like, let's say just printing hi. So whatever we want to do, we can explain in our comments and then we can code for it. So let's just say, what are the basic building blocks of Python? That we can print text, we can print numbers, we can print results of operations, like let's just say 3 plus 8. And we can also print statements. Like, for example, what does a statement mean? A statement means when you assert something, when you say something, like when I say 4 is more than 3, that's a statement. Statement is either true or false. So in this case, if we say 3 is more than 4, that's false. So on the screen, we will see false. So let's just see. So here, see, we got printed high, then we got 3, then 3 plus 8, we got 11, and then 3 is more than 4, we got false. So these are the different data types in Python. So text, numbers, I mean, you will see different kinds of numbers, but generally numbers, and booleans. Boolean just means true or false. So in this case, 3 is more than 4 is false, but if I say 3 plus 4 is more than 4, that's of course true. So we will see true now. So let's just say in Python, we have numbers. What kind of numbers? We have whole numbers and we have fractional numbers. Let's see. So 3 plus 4 is going to give us 7, which is a whole number. But let's just say 3.5 plus 6 is going to give us 9.5, which is a fractional number you can see with a dot. So in Python, this is called an integer. This is called a float. Now, what else do we have in Python? We also have, let's just say 3 is more than 4, which is, we know, false. This is called a Boolean. A Boolean just means true or false, basically. And we also have some text. Let's say my name is Nika. These are the main building blocks of Python. Let's just comment them out right now so that they don't bother us. We can just write these at the start of lines to make them comments that will be completely ignored. So now if I run this, nothing at all will happen because there's no code here. Okay, these are the main blocks of Python, but to do more interesting things, we will sometimes need to hold the results of these calculations somewhere. Like, for example, let's say we have this task that we know the Pythagorean theorem, which says that a squared plus b squared is equal to c squared. What if we have our a, which we know is, for example, 3, and b, which is 4? How would we calculate c? I mean, in this case, the autocomplete is giving me the answer, but I don't want to show it. We know from Pythagorean theorem that c would just be the square root of this a squared plus b squared. So what we can do is we can just first calculate that this thing. So let's just call it maybe sum of squares. We can give it whatever name we want. These are called variables, by the way. So here's the thing. 3 is a value. 4 is a value. My name is Nika is also a value. So a text, a number, or a statement can be values. But these values we can store in some place so that we can use it again. That place is called a variable. So in this case, a holds 3. So now if I say just print a, on the screen I will see 3 because a is 3. And if I say print b, I will see 4. So you can see here we get 3 and we get 4. By the way, you can write clear here to just clear the screen so it doesn't bother us. Okay, let's continue. So here we know that we have 3 and 4 and we want to calculate c. So what we want to do is we want to get the square root of the sum of their squares. So let's just calculate the sum of their squares first, which is a times a plus b times b. Or we could also just write a square plus b square like this. So this is equivalent. We can say a times a or a to the power of 2. They are the same. So it doesn't matter. And by the way, since this is a comment, this line will be completely ignored. So now if I print the sum of squares on the screen, we'll just see 25 because this is 9, this is 16, and together they make 25. Now, if you want to calculate c, we just have to take the square root of this. Now, how can we take the square root of a number? From math classes, you might remember that the square root is the same as power of half. So we could just say c is sum of squares to the power of half, and this will actually work. We can see here, we don't need to print this. We can see here that we would get 5. It says 5.0 because just in case it gets a floating number, the square root power already turns it into a float, but we know this is a whole number, but this doesn't matter right now. What matters here is that we saw that the power of half is the same as a square root. This is just from math, and because of that, we can see that c is the sum of their squares to the power of half. We could even write it together like this, times a plus b times b to the power of half, and just not use the sum of squares at all, like this. But this is just so we can make it more understandable. That's why we do it this way. Now this works, but power of a half is very confusing, and it's not very intuitive what this line is doing. So to make it more obvious, Python actually gives us a square root function. So what we could actually instead do is we could say math, that's square root, sum of numbers, sum of squares. And what this does is it will basically just give us a square root of 25. But in this case, we don't know what math is. So Python, just like many other programming languages, comes with some libraries that give us some code so that we don't have to reinvent the wheel every time. One of such libraries is math. And the way we can access it is by saying import math. And when I say import math, that allows us to basically use anything inside math. And one thing that is useful inside math is called square root. And this is a function, and we'll explore what function is in a moment. And here's what it does. It takes a number and gives us the square root of that number. So in this case, this will give us 5. But if we say the square root of 1, it will just give us 1. If we say the square root of, let's say, 4, it will give us 2. And in case you're wondering, if we give it square root of some number that doesn't have a root, like let's say 5, it will approximate like 2.23, whatever. And we can see that this is good enough because let's see if we print c times c. You can see it went back to 5. But pay attention, it's not exactly 5, it's 5.00001. And this is something important to consider about computers. So computers are not precise. They have to store numbers in their values, and they can't store the infinitely exact number, so they approximate. In this case, this is an approximation that goes quite a lot of zeros, but then there is a 1 in here. Now, the reason why this might be annoying is because this will not be exactly equal to 5 if we check later. So here's what I mean. Let's say we want to check if a plus, let's say print if a plus b is equal to 7. And by the way, here's some interesting thing to note. Um, this type of equality with one equal sign only means assignment. So this means that a is now 3 and b is now 4. But when we write it with two equal signs, we are just checking, is this true, is what we mean. So in this case, a plus b, which is 3 plus 4, is 7, so this is true, and we get true. Just like if we just say 5 equals 5, of course, we will see that this is true. But if we say, is c times c equal to 5, we'll see false. Because even though we know that sum of squares is 25, so here we can just print sum of squares again to remember this here. So c, which is the square root of it, sorry, this is, never mind. We know that c is the square root of 5, right? So c times c should again be 5. But as we saw before, c times c will actually be just slightly above 5, and so this will not be exactly equal to 5. These are just annoying things that we had to keep in mind. Most of the time, this will not actually block us in any work, but we just have to make sure to not forget such things. I will write you a note about every concept that we cover here, so don't worry about memorizing everything here, but just try to understand the main concepts going on here. So what did we do here? We introduced a square root function. Now let's properly write out what we wanted. So first, let's bring back our sum of squares, which I remind you is a times a plus b times b. And what we wanted is to take the square root of it. And so here we can see that c is equal to 5, right? So if a is 3 and b is 4, we know that hypotenuse in a triangle will be equal to the square root of the sum of their squares. So sum of their squares is this, and their square root is this. So far, are there questions? And I want you to ask questions, to be clear. Now let me see the chat as well. One moment. Right. So if anyone has any questions, feel free to ask it at any moment. I will be checking on the chat every minute or so. Okay. For example, Saba, would you like to go through this with me?
Oh, I don't know.
It's all right. We can take it step by step. The entire point is that we can learn together. So if something is not clear, we will repeat it, maybe phrase it differently, and we can go through it step by step. So first of all, the problem we're solving is that in a right triangle, the hypotenuse, so like squares of the sides are equal to the hypotenuse. So this a square plus b square is c square. Like this much is
Yes.
clear, right?
Of course.
So for that, here's what we do. First, can you explain these lines?
We have to find C, right?
Yes.
Yes, it's very easy. Like we should use the basic math and the square of 3 is 9. Then we have to add the square of 4, which is 16.
Mhm.
And after that we will find like the whole number of C square and we should like, how can I say it, decrease it and find what the word is. Like the final number is square of something. How can I say?
Yeah, yeah. I mean, yes, right. That's what we store in our sum of. Do you see my screen, by the way?
Yes,
Yeah. So yeah, you're right. We got the 9 plus 16 here, which is 25, and we put that in the sum of squares.
5.
But we know this is c squared. So to get
Yes.
c from there, we just took the square root of it.
Yes,
And
and it's
this,
5.
yeah, yeah, it is. And we see 5 here printed. Yeah,
Mhm.
when we print it on the screen. Okay. So here we saw what kind of data types we have in Python. And data type just means what value a variable can have. So like we have integer numbers, we have floating numbers, like we could say 4.5, for example. We have booleans. So let's just say, I'm just going to write out different things. Like we can say 3 is more than 4 here. This will just mean that d is equal to false, by the way. Let me just delete everything here so we can focus on what matters. So in this case, if I print D, what do you think will be on the screen?
False.
Yeah,
False.
yeah, that's right. So we just get false on the screen. Um, by the way, thanks Saba for the going through this with me. I know this is a bit stressful at first, but don't worry about this. We will all get used to this, and it's actually really good practice. All right. Now, uh, another type of value is text. So in this case, let's just say this is our first lesson in Python. I mean, not first lesson. First lesson was yesterday, of course. So in this case, if we print E on the screen, we'll see this is our first lesson in Python. So these are the different data types that we need to focus on in Python. So we have integer numbers, we have floating numbers. Basically, differences these are whole numbers and these are decimals. We have booleans, which is anything that is either true or false. And we can use more than sign, less than sign. We can use more than or equal to. We can say less than or equal to. We can say equals. And we can also say not equals, which is written like this. We will go through all of these together. Don't worry about memorizing them right now. Let's just get back to this. And we also have text. So this is called strings. Let's just write them out here. So again, this is now if our meeting time runs out, I'll just send a new link, by the way. Don't worry about that. Um, So these are integers, these are floats, these are booleans, which will be true or false, depending on what we write here. And these are strings, which is text that we put in these brackets. I mean, not brackets, but braces, these things. Um, Now, what's interesting is that we can combine them in some ways. For example, let's just say we have two pieces of text. First piece says, my name is, and next one, let's just say, says Nika. We can print E plus F, and this will give us my name is Nika. So we can basically join the strings together by saying plus. Just as 3 plus 4.5 would give us 7.5, my name is plus Nika will give us my name is Nika. Now there's a lot of operations that we can do with our code. Let's just go through them. We can do addition, subtraction, multiplication, division, powering. Let's just give it easier numbers to work with. And modulo as well. I will talk about modulo more. Let's just stay with this. So these are the main mathematical operations that we have. And I want to spend a moment explaining each one. So I will run this now, but first, here's what we need to care about. So let's just ignore everything above. I'll just write this again here. If A is 3 and B is 4, what will this write on the screen?
7.
Yeah. And this one?
-1.
Minus 1,
Yeah. Yeah. This one?
12,
Mm-hmm. This one?
0.7.
Yes, that's right. This one?
81.
That's correct, because 3 to the power of 4 is 81. And do you know what modulus is? It's not a trick question. It's completely okay to not have met this before. Let's just run this first. So yeah, you were right. This addition gave 7, subtraction was -1, then 12.75, 81, and 1. Now let's focus for a moment on modulus. Here's what modulus means. So we know that 10 is the same as 3 times 3 plus 1, right? So if we divide 10 by 3, let's just say 10 by 3, this is 3 and 1/3, right? So modulus asks, what is the remainder of the division? So for example, 4 modulus 2 will be 0, because we know that 4 perfectly fits 2 and there is no remainder. But 3 modulus 2, for instance, will be 1. And 10 modulus 2 will be 0, but 10 modulus 3 will be 1, because 9 is divisible by 3, and then 10 gives us a remainder of 1. For example, if 11 on 4 would give us 3, because 4 times 2 is 8, and then 8 plus 3 is 11. Now from this, let's just practice a little. For example, what do you think will be 15 modulo 7?
1.
Yeah, that's correct, because this will be, yeah, 7 times 2 is 14, and then it will be just 1. Let's just give it another try or two. So just make sure it fits in everyone just understands it. What would be 22 to the modulo 3?
1.
Yes, that's correct. It will again be 1. What about 24 on 4?
0.
0. Yeah,
Zero.
because 24 is exactly divisible by 4. So basically, percent just gives us remainder after division. And just only one more operation to cover before we get through the basic operations is, so here we saw that, for example, if our A is 10 and B is 3, A divided by B will give us 3.333, right? But let's just say we only want the whole part and we don't care about the fractional part. So in this case, maybe instead of 3.333, we wanted just 3. In that case, we have whole division, which is this. When we write it with 2 slashes, it becomes a whole division and we get 3 instead of 3.333. So let's see. A divided by B would give us 3.333, but A with 2 slashes would give us 3, because it rounds it to a whole number, basically. So these are our main operations. So main operations are addition, subtraction, multiplication, division, whole division, power, and modulo. These are the operations that we need to understand. I will give you homeworks which will involve every one of them so that you can practice them. But for now, let's just make sure that we understand each of these operations again. So let's just give that in here as well. Here, A was 3 and B was 4. So what do you think this would give?
0.
Let's see. You are correct. This gives us 0. Because what this does is it rounds it down to the nearest number. So with normal rounding, of course, 0.75 would become 1 because we round up if it's normal rounding. But this operation specifically rounds it down. So yeah, 0.75 would become 0. So let's just clear this rounds down to nearest integer. An integer just means whole number. Yeah. All right. So far, we've had different data types. So we have integers, we have floats, let's just write float. We have booleans, which are statements that are either true or false. So it can be 3 is more than 4 or 3 is less than or equal to 5 or whatever. We have strings, which is just piece of text. We can add the pieces of text, and we can do some operations on numbers as well. We can add them, subtract them, multiply them, uh, divide them and round them down to the nearest whole number. We can take a power of a to the power of b, and we can do modulus, which is just get a remainder after division. I will check if anyone has some problems, so feel free to write in the chat or to interrupt me and just talk at any moment. Now, right now, is everything so far that we did clear?
Yes.
Okay, good. Now, don't worry. I will, of course, send every piece of code that we write, and we will also have homeworks to understand everything. Now, I want to move on a little bit into something more complicated, and this is functions. Here's what functions would do. Functions would basically combine a lot of operations together. Now, first, for operations, let's just make up a problem that we can solve. For example, here is one made up problem. Let's say that, and I will just write for now. What I can write anything here. It doesn't matter if this will be ignored anyway, since this is a comment. So let's just say that here's our problem. Maybe we are going to send some robot on Mars. And let's just say we know what this robot weighs on Earth. Let's just say it's some X kilograms, let's say. And I mean, in reality, weight is force and it's measured in newtons, not kilograms, but let's not worry about that right now. And we want to know how much this will weigh on Mars. Now, what's the difference? Mars gravity, let's just go with is 38% of Earth's gravity. What this means is that if someone weighed 100 newtons on Earth, let's just say 100 kilograms equivalent. Let's just say if someone weighed 100 on Earth, he will weigh 38 on Mars. Now, our problem would be, what if we know our weight on Earth, but we want to know how much we would weigh on Mars? Let's say we want to make a function which will give our weight on Earth, and it should write to the screen what we would weigh on Mars. So here's what we would do for that. First, let's say that we would have the Mars weight coefficient. So Zoom has this annoying limit of, I think, 40 minutes. Yeah, 40 minutes, and that's why it exited. I'll see if I can do something about that, or if maybe we'll use that as breaks intentionally in the future. Anyway, let's just share the screen again. And okay, first of all, can everyone see my screen?
Yes.
Yeah. Yes.
Okay. Anmol, let's start with your question before we get into this task. So you asked, so everyone, he asked, can we add two different data types together? Now here we see we have integers, floats, booleans, and strings. Now let's see. Let's just do it right here. Okay, maybe not here, but like here. Let's say operations on different data types. So first of all, with integer and float, yes, we can add them, subtract them, multiply them, whatever. We can do anything with integers and floats. It will just assume as if both sides were floats. So let's just comment out these parts so they don't annoy us. So here we see, if we say 3 minus 4.5, we will get minus 1.5. We can also multiply them or divide them or even take a power of them, or even modulo, I think will work. Like this. Yeah. Yeah, it will work. So with integer and float, we can do anything we want. So this will be treated same as float and float. So we can add integers to floats. Okay. If anyone has a question, write it, and I will check both the chat and also you can just say it, of course. So for integer and float, we can see that anything works. Now let's see, with string and string, we also already saw that we can just add text to text and it will work just fine. String concatenation is just a fancy way of saying adding. So you can just say, this is string and string. We can also do, by the way, let's see if we can do this. So string and integer. And no, this will actually not work. So we can't do string plus integer. We'll give error. So let's just comment this out. So if we want to write, let's say hello, and then follow it up with some number, let's say in more realistic case, if I say that my age is 21 and my name is Nika, let's say I want to say my name is this and my age is this. Here's what I would have to do. I would say my name is plus name plus, and say I am. I would convert the age to string and then say years old. Now let's see what is going on here. First of all, you can see my name is Nick and I am 21 years old. Prints on the screen. What's this one? Maybe nothing. Okay. If anyone has a question, interrupt me at any moment. So let's break down what is going on here. So first it was string plus just string because we know the name is also a string. Plus a string again. So far we understand what's going on, right?
Yes.
And then we could not add the age directly because it's a number and we can't add integer to a string. So we used a function called str, which converts a integer or a float into a string. So what this does is before our age was 21, and after str, our age becomes 21, like written as text. So str age would be same as writing 21 as a string instead of 21. So this will be string, this will be integer. And this would convert it to an integer, into a string, I mean. And then we can add as many strings to each other as we want. So this is just another string. So here, for more clarity, when we could say age as a string, we could say str age. And here we could instead simply add age as a string. This would do the exact same thing. Now, so far, is this clear?
Yes.
All right. Let me see. Now, Amran, I hope. Sorry, Anmol, am I pronouncing it right? All right. So I hope I answered your question. So basically, we can add integers and floats, but we can add strings to other strings, But if we can't do directly strings and numbers, for example, we have to first convert them. So again, if you get any question at all, even if it's something we covered, just mention it so that we can go through it again. Because also remember, if you have a question, probably someone else also has a question and might just be too shy to ask. So it's actually helpful for everyone if you ask a question. All right. Now let's move into solving our problem here. So as a reminder, here was our problem. We want to send a robot on Mars, and we know what this robot weighs on Earth. Let's just say it's 100 kilos. And we want to know how much this robot would weigh on Mars. And yes, it's newtons, not kilos, but let's not worry about that right now. So we know that Mars gravity is 38% of Earth's gravity. So if you weigh 100 on Earth, you will be 38 on Mars. Similarly, if you are 200 on Earth, you'll be 76 on Mars, and so on. In principle, what would we want to do here if, let's say, our weight on Earth is some number, like let's say it's, in this case, I don't know, 150. How would we calculate our weight on Mars? Do you have ideas? So the key is that we know that weight on Mars would be 38% of weight on Earth. Let's do this together. For example, Salme, would you like to do this together with me? Oh, Yulia gave us the answer. Okay, thank you, Yulia. Yes, that is correct. So what Yulia said, if anyone missed it, is that weight on Earth, weight on Mars would be just whatever our weight on Earth was times 0.38. And the reason we use 0.38 is because 38% is the same as 0.38. And we can't write it as times 38% because that's not just correct Python syntax, but we can say 0.38 instead. So now we can just print our weight on Mars, and we can convert into string our weight on Mars. And we already know that this just means that we would turn it into a string so that we can print it on the screen. And here we can see that apparently weight on Mars will be 57 if our weight on Earth was 150. Now, to make it clear why we are using this is called the problem of magic numbers. So here, 0.38 is a magic number, which is bad. And it's bad because if someone goes in here, they might not understand directly why we used this number, like where does it come from. So to make it more clear, what we can do is we can say maybe something like Mars weight coefficient or something like that, and call it 0.38, so that instead of saying our weight on Mars is weight on Earth times 0.38, we can just directly say that weight on Mars is our weight on Earth times Mars weight coefficient. This way, our code speaks for itself. So one thing to consider is that generally, if you write a very good and very clear code with very obvious variable names, you will not have to use a lot of comments because the code will speak for itself. And this is much better. So if you write code such that you don't need to use comments, that is always a good thing to do, and you should always try that. Now, another thing to keep in mind is that some variables will change. That's why they're called variables, in fact, because they might vary. But some things we'll know will never change. For example, we know that pi will always be 3.1415 something. We always know that 2 plus 2 is 4. So some things we always know don't change. In this case, Mars weight coefficient we know will not change because no matter what our weight on Earth can be any number, of course, but this will always be the same value. This is why we introduced the idea of constants. Now, what does a constant mean? A constant means something that never changes. And in Python, there is just this standard, You don't have to do it. I mean, the code will work anyway. But when we have a constant, we write it in all uppercase. So instead, we'd say Mars weight coefficient equals 0.38. And generally, we would put this at the top of our program so that it's the first thing we see. So, and then we would say that our weight on Mars is again equal to our weight on Earth times this Mars weight coefficient. Of course, it doesn't matter at all if you write it in uppercase or lowercase. Python will work with it exactly the same way. But this is for constants that don't change, and this is for variables which will maybe depend on the situation. But this doesn't depend on the situation. I mean, in reality, after like a million years, maybe this will be different, but our program will probably only run for 10 years or 20 years in reality. So if it doesn't change at all in those 10 years, we will write it as a constant. Benefit of constants is that we don't have to worry about them. We know they will never change, and this makes it more simple to think about our code. Okay, is it clear what we are doing here so far?
Yes.
Just yeah, sorry, yes?
Yes.
Okay. So just to go through it once more, we said that our problem is that we want to know what our weight would be on Mars if we know some weight on Earth. In this case, we said that our weight on Earth was 150. And for that, we just had to calculate it by multiplying by 0.38. But instead of doing it directly, we decided to create a variable so that we would understand what we are doing when we look at our code. So if you just look at line 72 here, weight on Mars equals weight on Earth times Mars weight coefficient. So instantly you understand everything that is going on just by looking at this one line. So as opposed to if we were to just say here 150 times 0.38, you would be like, I don't know what this is. What is this? What is this? But by giving them clear variable names, we know what's going on. And here's what I mean. We could instead just call this like A and B, and we could just say weight on Mars is A times B. But now we don't understand what is A, what is B, where do they come from. So always, always try to give obvious, clear names to every variable, even if it's too long. So Mars weight coefficient is obviously a lot longer than just typing B, but it's also a lot more obvious. And making it obvious is a lot better. Your code will not be any slower just because your variable name was longer. Your code will work exactly the same anyway. And this just makes it easier for any human who has to look at the code. So always keep in mind that whatever code you write, other humans will also have to look at it, and you in the future will have to look at it. So try to make it as easy to understand for both you in the future and maybe other people as possible. So far, is everything clear?
Yes.
Yes.
I will periodically check the chat again. And let's just wrap this up by giving this a better structure. So first of all, let's just say, what did we do here? We have our constant. We just need to multiply to get our value, and we want to print it on the screen. Now, let's say we want to do it multiple times for a lot of different weights. So let's say now my weight on Earth is 100, and I want to calculate it again. I would have to write this line again, and then I would have to write this line again. Now, if my weight on Earth is, let's say, 50, I would again have to write this again, and so on. So every time we wanted to calculate for a new weight, I would have to write both of these lines. Now, what if I don't want to repeat this kind of code? Because repeating code is generally always a bad practice. Because now, let's say I want to change something about this. For example, I want to instead say weight on Mars is. Now I have to change it here, and here, and here, and everywhere I use this code. So a better way to reuse the code is to create a function. So let's see what that would look like. So instead of writing them out like this, here's what I would say. Let's create a function that will give us our weight on Mars. So first we say def, which just means define. And let's just call it something obvious, like give weight on Mars. And let's say it takes as an argument, and by the way, argument just means that we can pass it whatever. In this case, weight on Earth. and it will simply calculate the weight on Mars exactly the same way as we did before. So it will do this, and then it will write it to the screen exactly like we did before. But now, because we have this function, we don't have to repeat this every time. Here's what we can do now. Now we can just say give weight on Mars for 150 kilos, for 200, for 100, maybe also for 50. And in each case, it will just say, here's your weight on Mars, here's your weight on Mars, weight on Mars, weight on Mars. And the benefit of doing it this way is that we can also write, and we can make some changes here. Like say we also want to say weight on Earth was this number. And here we can see, and maybe let's just write print. And by the way, when you write print like this, it will just skip a line without putting anything on the screen. So here, you can see now there is this emptiness between them, which makes it easier to understand. This is done by just writing print, because print always ends by ending the line. And this way, yeah. So because we put this in a function, any change we make here will apply automatically every time we call this. So this is very useful, and this is called a function. This is a function. And we write it by saying def, so that we can define it. We give it a name, whatever name we want, doesn't matter. We give it as many arguments as we want. In this case, we only gave it the argument which is weight on Earth. Because based on the weight on Earth, we will calculate the weight on Mars. And notice it also used the Mars weight coefficient. We did not have to pass this because you can already see it. And we didn't pass it because we always know that it doesn't change, so it just takes from this constant. And here we just say weight on Earth is converted to string weight on Earth, and weight on Mars is this. All right. Now, is this clear?
Yes.
Right. We will have some homeworks similar to this so that you'll have more chance to more deeply understand what we are doing here. But the main idea is that we can make any function which maybe takes arguments, maybe doesn't, and it can do any number of things. So let's just go through some examples of that. Let's say we write a function that just writes stuff on screen. It doesn't even take any arguments, and it can just say print hello world, print this is a simple Python script, print let's learn some basics of Python. Oh, and yeah, let's call it. Of course, here's something interesting. If you never actually called your function, it will never be used. See, the weight on Earth was used because of this, but this code never ran. But if I do call it, well, it'll be used. So here you can see, hello world is a simple Python script, let's learn some basics. So a function might not take any argument. Maybe it will, maybe it won't. It can also take multiple arguments. It could take multiple arguments. Like, for example, remember earlier when we calculated the hypotenuse in a triangle? Let's do that again. Get hypotenuse. So let's say we take A and B, and we know that C is equal to this, A squared plus B squared to the power of half. By the way, is this line clear to everyone? Just this line.
Yes.
So we take the squares, we sum them, and we take the square root of it, which is how you get hypotenuse in triangle. And let's say now instead of printing into the screen, we return it. Here's what return means. So let's just say here we say hypotenuse, sum A, which is 3, sum B, which is 4, and hypotenuse, which will be equal to get hypotenuse of A and B. Now if I print on the screen the hypotenuse, you can see here I get 5. So because we wrote return, let's say if we didn't write return, we would get none, because by default variables are assigned none, which just means that there is nothing inside there. So hypotenuse right now is none. But if I say it equal, here return C, what that means is that when we call get hypotenuse, C is returned. So C is returned. And this means that here 5 is returned. And so hypotenuse becomes equal to 5. And here we can see, yeah, 5. So could take multiple arguments and return a value. So any function can take 0, 1, or as many arguments as it wants, and it can return a value. So it can return C, it could return anything, or in this case, we return nothing at all. Is this clear?
Yes.
Yes. Yes.
All right. Now, to be clear, here we see print, right? That we've been using all this time. Print is also a function, but it's a function that Python gives us. And this function, you can see here from documentation. By the way, documentations just give examples of how to use it and just explain it, but we don't need to understand any of this. Main thing you need to understand about print is that you can pass it some text or some number or some boolean, basically just anything, and it will put it on the screen. So this is just a function as well, just like our write stuff on screen or our get hypotenuse. These are all functions. And similarly up here, if you remember back when we did this with math.square root instead. So if you remember when we did this, math.square root, this square root is also a function that just lives in the math library. Let me just return the code. Yeah. So Python uses functions a lot. It has a lot of built-in ones that we take for granted and we can use daily, and we can make our custom ones as well. This is a very important point to consider. Now, the only other main thing that I want to explain to you before I free you for today is conditionals, I mean. So previously we already saw that we have booleans which can just check different statements for if they are true or not. Like we can say, is 5 plus 5 equal to 10? Is 8 less than 3, or less than or equal to 3 even? Is 4 more than or equal to 4, and so on. So in this case, we can see 3 is more than 2 is true, of course. 3 is less than 4 is true. 5 plus 5 equals 10 is true. 8 is less than or equal to 3 is false. And 4 is more than or equal to 4 is true. And let's just add another one, which is 5 is not equal to 4. Not equal is written with like this. And here we can see this is true because, of course, 5 is not equal to 4. Now, the reason why we care about doing these things is because sometimes maybe we want to have conditional logic. Here's what I mean. Maybe, say we are at a bar and we can give people drinks only if they are more than 18 years old. For example, let's say our age limit is 18, but our client's age is, let's say, 15. Now, in this case, we can say if client's age is more than or equal to age limit, and this is if-else conditions that I'm explaining right now. This is new code, so don't worry about it. And for the first time, we are using indentation, which is a rewrite colon here, and then we put code inside here. This means that whatever code I put here will only execute if this is true. So you can see here, this is just a Boolean like this. So here I can say print, okay, you can drink. Else, we say, no, go home. So in this case, we see that we got no go home. Let's just, never mind, we have a lot of text anyway. So here you can see if our age limit is 18 and our client's age is 15, we check if our client's age is more than or equal to age limit, then we say you can drink, otherwise we say no, go home. So now if I say client age is 25, we can say, okay, you can drink. So basically, whatever we put in here, if it's true, we will execute this code. If it's not true, we will execute this code. Is this clear?
Yes.
Yes.
All right. Now let's do a little bit of chaining. Let's say our rule is that for kids under 8, a ticket is free. For for kids 8 to, let's say, 18 years, 8 to 17 years, the ticket price is 5 lari, or let's say 5 USD because we have international people. And for adults, the price is, let's say, 10 USD. And let's say we want to create a function, def, again, calculate ticket price. And again, remember, we can name it whatever we want. Let's say the only argument we get is age. And we want to return the correct number. How would we do this? Now, the key here to consider is that here we have 3 rules, right? First rule that if your age is less than 8, price is 0. If your age is between 8 and 17, price is 5. And if your age is more than that, your price is 10. So we can do that again by writing ifs like that. So let's say if age less than 8, we simply return 0. So what this means is that, again, remember, return just means that when we call this, it will turn into this number. Okay, so later here we can say price equals, and let's say calculate ticket for price of, let's say, a 5-year-old. And we can print here, price for a 5-year-old was price. Here, let's just say else, I don't know, return 100. We know this is wrong, but for now, let's do it this way. We see here that price for a 5-year-old is 0. So this works correctly for this part of our logic. But now the next thing we want to do is we want to check what if your age is between 8 and 17. And the way we might do that is here. Now, aside from if and else, there is one more thing we can do, which is elif, which just means in case this was not true, but we have another condition. The other condition is what if age is more than or equal to 8 and age is less than or equal to 17. In this case, we want our ticket price to be 5. And else, if you're an adult, we want the ticket price to be 10. Now here's what we can directly do. We can directly say, calculate ticket price 5. Now let's see price for a 10-year-old. And again, let's just directly say, convert to string, calculate ticket price for 10. And similarly, let's write for a 20-year-old price of 20. And in this case, we see for a 5-year-old, we got a free ticket because this part executed. For a 10-year-old, this part executed. And for a 20-year-old, this part executed. Now I want you to ask me some question about this code.
If we wrote incorrect numbers and returned for ages between 8 and 17, what it would write?
Can you repeat the question?
If we wrote incorrect numbers in return for ages between like 8 or 17, like if we wrote 20, what it would write below?
Yeah, here, like this is for 20, right? This line. And for 20, it gives us 10 because it's more than 18. For 10 here, which is between 8 and 17, we got 5. And for age of 5, we got 8. So in this case, whatever number we write here becomes age variable. So age here is a variable, and it is assigned when we write something here. We could assign it like this, or what we could do is we could say age of a person, let's say, equals maybe 17 exactly. Let's just write 17-year-old. And here we can say calculate ticket price for age of a person. In this case, what do you think this will say?
5.
Yeah, exactly. For price for a 17-year-old is 5. Why? Because this is age more than equal to 8 and less than equal to 17. And by the way, one more thing. Here, because we are checking that age is less than 8, and if it is, then we return 0, we know that if we got this far, if we reached this code, age must be more than or equal to 8. So we don't actually have to do this check. We can just remove it. Because here, we already know that age is more than or equal to 8 if we got this far, because otherwise we would have returned here. And similarly, if we reach this far, we already know that age is more than 17, so more than or equal to 18. Because we know that if it was 17 or less, it would execute before. So that is why here we know if it's under 8, the ticket is free. Otherwise, if it's under 17, we say it's 5, and otherwise we say it's 10. Is this clear?
Yes.
All right. This is good. Now, the only last thing that we should consider in our last 5 minutes of this meeting is this. So we saw if, we saw else, and we saw elif. And by the way, we will see more of this in the homework, so don't worry if this is overwhelming right now. There will be a lot of examples in the homeworks. Now, another thing that I want us to do is to understand loops. And this is the last topic of today. Here's what loop means. Instead of if, so when we write if, we can say like if age of a person is more than 16, in this case, I know this is 17, we'll say print, oh, you're not a kid anymore, huh? Just some text, right? Doesn't matter. Here we can see, so if this is the case, this will happen just once. And if it's not the case, like say if age of person is 5, we don't write anything to the screen in this case. But what if some condition is true, then we want to write something on the screen multiple times as long as it's true. For example, what if we want to count down from 10 to 0? So what I mean is, what if we want to write like print 10, then print 9, then print 8, and so on, all the way down to 0? A simple way to do this, of course, would be to just do it like this. Print 6, print 5, or 5, 4, 3, 2, 1, and 0. But as you can already tell, this is annoying, very slow, and just not the best way to do it, because what if you had to do it 100 times? So a good way to do this kind of doing the same task multiple times, is with a loop. Now here's what a loop means. So we knew that in if, whatever we wrote would execute once, right? In a loop, whatever we write will keep executing as long as some statement is true. For example, here, let's say we have a countdown, and it's equal to 10 right now. And let's say while our countdown is more than or equal to 0, we would do some actions. So in this case, maybe print countdown, and then decrease the countdown by 1. And what do you mean by decrease the countdown? We can say countdown equals countdown minus 1. So let's see what happens in this case. Let's delete this. Here we can see on our screen that we got 10, 9, 8, 7, so on, all the way down to 0. What happened here? We got a variable, we called it countdown. We set it to 10. Of course, we could set it to whatever we wanted. Maybe even 5, for example. And as long as it was more than or equal to 0, we executed these statements. And statements in this case were print it on the screen and then decrease it by 1. Countdown equals countdown minus 1 just means countdown will be assigned the value of countdown minus 1. So if it was 5, it will become 4, then it will become 3, then 2, then 1, then 0, and then eventually it will become minus 1. And when it becomes minus 1, this is no longer true and it will no longer happen. So to be clear, after we have exited the loop, countdown is now, let's see what countdown now equals. So you can see once it has exited, it is now equal to minus 1. And by the way, if we forgot to decrease it and just kept it like this, let's see what would happen. We would keep writing 5 on the screen forever, and our program would never end. So this part would never be reached. This is called an infinite loop. And what this means is that countdown is always more than or equal to 0, So we just always keep printing countdown. This is annoying, as you can see. Similarly, if we said that instead of decreasing it, we increase it, of course, it will always be more than 0 in that case as well. And we can see it just keeps growing really fast, and this will just keep going. Do you have any questions about this? Thank you, Anmol. How to take input from the user. Let's cover that one really quickly. And then with that, I guess we have our basics out of the way. Okay, let's see what that means. Taking input from user. So as you can see, I'll explain this in a minute. So far, every variable we wrote by hand. But what if we want to ask a person what his name is, for example? Here's what I could say. Name equals input, which is a function in Python. We say, what is your name? And then we'll just print hello name. Here's what this looks like. Oh, yeah, sorry, I forgot to turn off this loop. Right, so we say, what is your name? I say Nika, for example, and it says, hello, Nika. This is the syntax that lets us to take input from the user. So we could also say,